Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. Today we are going to answer January 2021. Okay, as usual, okay, you have to start from question 11. Do not waste your time in the multiple choice questions and try to answer as much question as fast as you can. And any question that needs some time from you, or you think that your answer is not perfect, put a mark on it. Okay, so you can return back to it, especially the star questions or the questions that need explanation. Okay. Tamam? Yes, let's go on to question number 11. And as you can see here in question number 11, because it's from the picture, they are talking about moment clockwise and moment anti-clockwise. A uniform plank of length 4 meters, that's the whole length, 4 meters. And they said uniform. Who can tell me what's the meaning of uniform? When they mention the word uniform, what that means? Yeah, send it to me, if you please. What's the meaning of the word uniform? No, that means balance. Okay, balance means all forces are balanced, means equilibrium. When they said equilibrium, that means all forces are balanced or cancel out each other. Yes, thank you, Hamza. The center of mass is exactly in the middle of the shape of the object. So exactly 2 meters from both sides. That's what the weight, okay, of the plank. The plank or uniform object, that means the weight act exactly at the center of the object. Okay, 4 meters, that means 2 meters on both sides, pivoted at 0.9 from one end. Okay, the weight of the plank, it's 250 Newton. A person of 950 Newton stands on one end of the plank, as you can see. Okay, a person of weight 650 stand at the distance x from the pivot. Okay, and it is equilibrium. Now the word equilibrium means the resultant force equals 0. That means it's balance. Okay, there is no resultant force acts on it, as shown. Add part A, add to the diagram to show the forces act on the plank. What are the forces act on the plank? As you can see, we have two normal reactions. Okay, I'm sorry, my mistake. There's the weight here, which is 650, and the weight here, I'll put it longer a little bit because it's bigger, 950 Newton. And what? Add to the diagram the forces act. That means the weight here and the weight here. This is the weight for the first person, number 1. This is the weight for the second person, number 2. And there is a normal reaction from the pivot, acts where upwards. That's the normal reaction. And the normal reaction, I draw it more than both of them because it's equal to both of them according to resultant force equals 0. That means forces up equal forces down. Okay, now it's only labeling without the length, but I did all think if there's extra marks, and if there's on the mark scheme they have different idea on different questions similar to it. Now calculate the distance x. Now as we can see, because they said that it's uniform, it means two things: that the resultant force equals 0, and what else? Resultant force equals 0, and yes, exactly, resultant moment equal also what? 0. Exactly. Shukran. So now they need to find the distance x. Now I know that forces up equal forces down. I can find the normal reaction, but I will not use it if I say that I will do the pivot. Okay, the point of rotation about this point. The normal reaction does not make any moment because the distance between it and the pivot that I choose it is 0. Okay. So that means I have two moments here. Moment clockwise caused by what? By this weight about the pivot here. And moment anti-clockwise by this person about the pivot, because this one acts to the right, so the moment clockwise, and this one acts the weight of it downwards, so it will be anti-clockwise. So that means moment clockwise and total moment anti-clockwise, they have to be what? They have to be equal. Now, who make the moment clockwise is this one, which is 600, the force multiplied by time, 600, okay, multiplied by the distance that we are labeled it x. And the other one, it's the force 950 multiplied by the distance. Usually I change the color, not necessarily here. So the distance here is x, and the distance here is how much? 0.9. These are the only moment that acts here. Are they? I did a mistake. What's my mistake? Who can tell me what's my mistake? Yes, what's my mistake? Shukran. Yes, the weight of the plank exactly in the middle of the 4 meters, there is the weight of the plank acts downwards. And how much the weight of the plank? Exactly 250 Newton. Bravo. And this also causes what? Another moment, what? In the same direction of what? Of the clockwise. So 250, okay, multiply by the distance, which is exactly in the middle, which is 2 meters. You have to be careful. I thought that's one of you will tell me, Sad, you did a mistake. So 250 times 2 plus the other moment, which is 650 multiplied by what? The distance x, okay, equal 950 multiplied by 0.9. Now, by using the calculator, how much is my answer? How much the distance x? Distance x, it will be how much? 0.89 meters. Okay. Bravo. I did another mistake. Bravo, ya Amir. Why? What's the other mistake? That I'm talking about the distance not to this end. Bravo. I'm talking about the distance to the pivot. Exactly. هلا هيك صح قبل شوي ما كنتم صحيحين. So the distance here is supposed to be what? 2 minus 0.9. Okay. So I'll write it 1.1 here. Exactly. برافو. هلا هيك صحصحته. وين هذا أول سؤال لازم نصحصح. فبيطلع finally الديستانس تبعتي equal 0. what? Where is it? 0.89 meter. That's how far is the smaller person sits to the right to the pivot. Tamam? So again, from where I get this value, it's 2 meter minus 0.9. Good. Tamam ya shabab. Any question? If you please take screenshot here, okay, for all the answers that we have labeled. تمام هيك؟ Any question? في واحد بحكي طب استاذ ممكن ترى تظبط لنا الارقام لانهم فوق بعض. حاضر هلا بنظبط لك الارقام. 2 ايش 600 ايش 50 نيوتن. هيك كويس؟ ماشي. بنظبط لك هذا الكالر يكون الاحمر يعمل لنا المومنت بهالطريقه هي. اوكي. Okay. That's better. You can take screenshot if you please. Okay, let's move on to the next question. I am happy that some of you tell me that there's mistakes, not one mistake. Good. I did that in purpose. I want to see who's attention and who's not. شكرا لكم يعني انتم انتبهتوا. طيب. Question number 12. I will do a mistake also. ماشي؟ يلا. Moving Ash Walkway, okay, are often found in airports, okay? One moving Ash Walkway carries passengers up an incline of the 30 degrees as shown, okay, going up with a 30 degrees. A single passenger of mass, they give us how much the mass, stand on the walkway. The speed of the walkway is what? This is the speed and its constant speed, 0.51 meters per second. Show that the rate at which the walk does work on the passenger is how much? 2000 watt. So that means I will use this value, okay, in the other parts, okay, part B or C. Yes. So what I'm going to do here, I will say that power, because the rate of doing work, that means it's power, right? The rate of doing work, it's power. So I will say that it's force multiplied by what? By velocity. Can I say it like this? And the force is the weight, which is 72 times 9.81, multiplied by the velocity, and we get the correct answer. صح? What's my mistake? I did a huge mistake here. Why they give us the angle? So we have to resolve the velocity. I'm talking about the velocity vertically upward. Exactly. So maybe it's better for me to not use this equation here. Okay, if I want to use it, okay, it will be a little bit difficult for some of you. So we know that power equal work divided by time, and the work is the force multiplied by what? The distance divided by what? The time. So as the passenger is moving at steady speed in this direction with an angle of 30 degrees, how much the increase of the height every second? So the force, which is the weight, mg, and the distance is the height, h. I'm talking about gravitational potential energy. Divide by what? Divide by 1 second, because I'm talking about every second. So the height, h, how can I find it if I know that the speed here? Exactly. How do I know that? I have a right angle triangle here, okay, that has an angle here 30 degrees. And I don't like to draw on the same picture. That's why I'll draw it here again. So the velocity here, okay, it's how much? 0.51, and the angle is what? 30 degrees. So how much is the height every second? We know that sine 30 equal the opposite divided by the hypotenuse, which is what? 0.51. So by doing cross multiplication, h equal how much? Half 0. Exactly. Sine 30, which is half, so it will be 0.255 watt meter. I'll substitute it here. So it will be 72 times 9.81 multiplied by 0.255 divided by 1, and I will get the answer. And how much is my answer? How much is the answer? It will be approximately how much? Yes, shukran ya shabab, 180 watt, which is about what? 200 watts. So we will use 180 now. If I didn't do this mistake. If I put the values, I will not get the value 200. Teacher, I have another method. Yes, the other method, you can write the force, okay, multiply by sine 30, divide by, exactly, you can do that. Shukran ya Hamza. I can do the opposite way. Yes. Bravo عليك, shukran. And we still get the same answer. Tamam? Now let's move on. The walkway system is how much efficiency? How much? 78%. Calculate the power input, okay, to the system when how much? 15 passengers of the same what mass, okay, are standing on the walkway. Now that means efficiency equal power out divided by how much? Power in times 100 watt percent. Now 1 passenger, he did this approximately power, okay, that's the output power, okay. So 15 passenger, that means the output power I'll multiply by how much? By 15. So it will be 15 multiplied by 180. That's what actually happened. Okay, the final output work. Divide by what actually input. Okay, so the efficiency, which is 0.78, I remove the 100% here. Okay, divide by power n, and by doing cross multiplication, my answer will be how much? How much the power n? It will be, yes, thank you. It will be 3,660, which is approximately 3,500 watt. This is question number 12. You can take a screenshot for it. Any question? Is it clear? If it's clear, if you please put thumbs up. If it's clear, put thumbs up. If it's clear, thumbs up. If it's not clear, hands up. If it's not clear and if there's something that you didn't understand, hands up. Okay. في ناس ما رفعوش ايديهم ليش؟ اوكي تمام، شكرا يا امير، شكرا يا هنا. طب what about the rest؟ حمزه وشاهد. اوكي خلص هيك يعني منى تمام، ما فيش حدا رفع ايده انه مش فاهم. اوكي next question 13. A rugby player kicks a ball off the ground with an angle of how much? 35 degrees, like this. Okay, projectile motion. to the horizontal as shown. The ball reached the maximum height 5 meters before return back to the ground. The maximum height was how much? 5 meters. Show that the initial speed of the ball is how much? 17 meters per second. That means I will use this value where in the next part. Now, since they give us the vertical height and they give us the angle, now we know that we are talking about here vertical motion. Okay, so that means u in the y-axis vertically equal u what, sine or cosine 35? Yes, sine or cosine, send it to me لو سمحتوا. Yes, sine. شكرا صح bravo sine. Sine what? Theta. So that means I need to find u. The question asked about u. So u equal what? U in the y-axis divided by what? Sine how much? Sine 35. Okay. How can I find u in the y-axis? Now that's why. Aha, bravo. I know exactly. Vertically, I will use so that. So the distance, which is 5 meters, and the initial speed is initial speed in the y-axis, and as it reached the maximum height vertically, it has a 0 speed, and the acceleration is negative 9.81. And what? I don't have the time. They ask about the initial speed. So which formula I will use? That doesn't have t. I will use the formula v square exactly equal u square. Let me write it down here. Okay, I will use the formula v square equal u square plus 2as. So 0 square equal u square, that I want to find it out, minus, because the acceleration is negative, 2 times 9.81 multiplied by 5. So that means u equal square root of the answer. And that means u and the y-axis, how much it is? Square root of 91 exactly 98.1, which is 9.9. Yes, 9.9. Now I will substitute this value where? Here. And my answer will be how much? 9.9 exactly divided by sine 35, which is equal to how much? 17.3 meters per what second. Yes, shukran. 17.3 meters per second. Excellent. شكرا لكم. تمام. Take screenshot if you please, or write down your information. If you have a question, you can ask me. I have no problem. Okay, so I know the initial speed. This value, I will use it in the next part, 17.3. What this is? Okay. B. After traveling a horizontal distance of 22 meters, okay, horizontal distance 22 meters, the ball reaches the goal. Okay, so the range in the x-axis, the distance in the x-axis is how much? 22 meters. The ball reaches the goal, and they said to score the ball must be more than 3 meters above the ground to reach what to goal, to what make a goal. Deduce whether the initial speed 13.0 or okay, they give us 13.0, not 17.0, not 17.3. Okay, is sufficient to score or not sufficient? We have to determine the height that it will reach by this initial speed. So I'm talking about here vertically and horizontally. Okay, so that's why we have 3 marks. Now we know that the initial speed in the y-axis is 9.9. That means I have to find the what? Okay, they ask about the distance exactly. So I'm using so that now. I'm using so that. So S is supposed to be 3. Okay, U it's 9.9. V I don't know about it. Okay, and the acceleration it's negative 9.81, and the time I don't know about it. Now I want to make sure that the height is what? Is 3 or not. So what's missing here? The V, I don't know it, or the time, I can find the time from what? The horizontal component of the velocity. Yes, thank you. Yes, shukran. Can I explain the question? The question asks, does the ball make a score? Okay, when he kick it like this and goes above to what? To 5 meter maximum height, does it reach the goal above or below 3 meters. So if it's above, that means he scored. If it's below, that means he doesn't score. So I need to find the distance, okay, the vertical height when the ball reach, covering a distance of how much? 22 meters. So the horizontal component of the velocity, I have to find it out. So that means the velocity in the x-axis, hold on, let me put it silent. Yes. The horizontal in the x-axis equal what? The speed that we just, they give it to us, 17. What? Cosine what? Cosine theta. So 17 cosine, the angle was 35. How much is this value? How much it is? Yes, 13.9. Shukran. Cosine, not sine. Cosine, yes. Okay. They tell us 17. Deduce with the speed. Okay, I will use their value because they ask about its value, the value itself. Okay. Tamam. We can write 17.3 or 17, but 17 it's better. Okay. So it will be how much? 19.3 meters per second. That's the horizontal speed. Then what I will find? I will find the time as it traveled how much? The range of how much? That of 22 meters. So that we know that distance in the x-axis equals speed in the x-axis multiplied by the time. So the speed, the range here, which is 22, equal 13.9 multiplied by the time. So how long it will be the time here? The time here, it will be how much? The time here, it will be 1.858 seconds. Now I will substitute this time here, 1.85 watt second. Then I will decide if it's sufficient or not sufficient by finding how much? By finding the distance. So which one? Okay. How do you know that the distance? Okay. Now horizontally, I will use distance equals speed times time. Vertically, I will use so that. That's why I shifted from beginning. So from here, I will use the formula S equal UT plus half AT squared. So initial speed, which is a 9.9, I'm talking about vertically here, multiplied by the time that we just find it out, minus half times 9.81 times 1.58 square. And by using calculator, the answer, it will be how much? How much is the answer? Yes, it's 3.2. 3.2 meter, and which it is bigger than what? 3 meter. So yes, it is sufficient to make a score. Yes, it makes a score because it's above how much? Above 3 meters. Are you sure? You check your calculator if you please. طيب مش مشكلة يعني الفكرة both answer 3.2 or 3.6. I don't have a calculator. I calculate take fast with my hand. Okay. طيب Hamza said that it's 3.6, not 3.2. Okay, in both ways, 3.6 is greater than 3 meters, so it makes what? A score. Tamam? So again, yeah, Shahid, what they said? They said that the goal here, it's far from the point where we kick it by how much? 22 meters. Now, it goes maximum height somewhere here, then fall down. Okay. Now we don't know if it falls down below or above what? The goal, or below or above the bar. Okay, the score, which is how much? 3 meters. Okay, above the ground. So we have to know how much the distance that it reached. So we have to know how much is the distance. Now, as you can see, we know that u from the previous part, 9.9 in the y-axis. Okay, we know that the acceleration is negative 9.81. Okay, we have to find the time. So I use the horizontal range, okay, here, the horizontal range, which is speed multiplied by time, horizontal speed multiplied by time to find the time. But I have to find how much is the horizontal speed by using Vx equal u cosine theta. Because in the beginning, I have to resolve the question, okay, resolve the forces, one vertically and one what? Horizontally from the beginning. So the vertical one, we find it out 9.9. The horizontal, which is 17 cosine 35, which is how much? 13.9. Okay, so I measure how long the time it was taking that to cover the 22 meter. Why? Because it's a constant speed. Okay, horizontal it's constant speed, so I use distance equals speed times time. To find how long is the time, I use this time where in the y-axis to know how much is what the vertical distance it reached after this time by kicking, and it was above 3 meters. Any question? Is it clear now? هلا في ناس طلع معي الجواب 3.4، في ناس طلع معهم الجواب 3.2، طلع الفاينل انسر 3.6. Use the calculator and check. 9.9 times 1.58 minus half times 9.81 times 1.58 square. Use the calculator. How much the answer? It will be greater than 3. Okay, there is a score. If it's less than 3, there is no score. But your answers, I have 3 answers by using calculator. 3.2, 3.4, and 3.6. I don't know what's written in the mark scheme. Hold on, let me check. Okay. Yes, it's 3. Yes, it's 3.20. 3.2 meter height. Okay, let's check the values. Okay, the cosine exactly, the distance here exactly, and this is 9.8. I put 9.9 and here it's 9.8. That's why 17. 17.3 not 17. That's why. Okay, خلاص مش مشكلة. So this is the mistake. Okay, خلينا let me fix it. It's 9.8, 9 point here and here 9.8. Okay, and the answer here it will be what? 3.2 meters. Now I think it's correct. Is it? Yes, thank you. How do I get 9.8? Okay, by putting 17 sine what 35, which is what 9.8. That's why there's 5 marks on this question. Look how many steps. 1, 2, 3, 4. 4 steps to answer this question. Okay, let us continue. Oh, this question, I remember one of you, I forget who, he sent me this question before. Okay, what the question asked? The photograph shows a fireboat, okay, used to put out fire, okay, on ships at sea. Okay, a pump fixed to the boat pumps water from the sea. Okay, the seawater is projected at a high speed out of what the pipe connected to the pump. Next, this is the picture. Okay, the mass of the seawater pumped every second, okay, every second is 300 kilogram. The pipe has a diameter of what? This is the diameter, which is 0.1 meter, and the radius, it will be 0.05 what meter. Okay, so again, we have to know how much is the radius, because they will give us that this is the area and find out the rate of coming. Let's ask. So the radius is 0.05 what meter. Okay, the density of the water, seawater, is 1030 kilogram per cubic meter. Show that the speed at which the seawater projected from the pipe is approximately how much? 37. That means I'm going to use this value in the next part. So how can we find this? Now, they give us the density and they give us the mass. Density and mass. And we know that the cylinder here, the pipe has a cylinder shape. That means every second, there is 300 kilogram of water come out from here. So if I know how much is the length here, this length every second, this distance divided by time, which is 1 second, is the speed. So the volume of the cylinder, as all of us know, it's equal what the base area multiplied by the height, right? Which is the length that I'm talking about. The base area multiplied by the height. So that means the volume equal pi r square multiplied by L. I will call this distance L because I'm going to find it out. Yes, shukran ya Shahid. No, I'm talking about the volume of a cylinder. Be careful, not the volume of the sphere. Okay, شكرا. طيب في شباب بلش يبعثوا لي الأجوبة. Yes, exactly. We have to find using the density how much is the mass every second. Okay. Okay, so density equal mass over volume. Okay, so that means the volume equal mass over density. The volume, which is pi r square L, equal m divided by rho. So L equal, that's what we want to find, divide every second. It's equal to m divided by pi r square rho. By putting the values here, we get the correct answer. So 300 every second divided by pi multiplied by the radius, which is 0.05 square, multiplied by the density, which is 1030. And yes, by using the calculator, how much is your answer? Yeah, bravo Shahid, shukran. It's exactly 37.1 meters per second. So we get this value. شكرا يا شهد، برافو عليكي. طيب شكرا يا حمزة، يسلم. مين كمان بعت لنا أجوبة؟ أوكي، حمزة وشهد. مين كمان؟ نور. شكرا يا نور، برافو عليك. So what we did here, it's only 2 steps. Here, 1 step, we substituted here. That's it. This the second step. And we the third mark, okay, it's how to convert from diameter to meter. And the final mark is to get the answer. 4 marks. 1 mark here to find the value of this. Okay, 1 mark here to use this formula. Okay, and 1 mark to convert from diameter to radius, from centimeter to meter, and 1 mark to show the correct what answer. Okay, yeah, let's go on. Next. Now, we don't forget this value. It's 37.1. We're going to use it now. What they ask. Determine the rate at which momentum of the seawater is changed by the by the pump. You may assume that the seawater initially stationary. So delta rho equal rho final, momentum final, minus momentum initial, and momentum initial is 0. How much the momentum? M multiplied by V. So the mass of each second, it's 300 kilogram multiplied by what? 37.1. And the rate of changing of the momentum, it will be how much? Yes. Yeah, it's divided by 1 second. So that's why we exactly. So I'm not going to do that. So it will be 11,100 approximately. So it will be 1.11 times 10 to the power of 4 what? What's the unit of momentum? No, Hamza, be careful. Okay, now why you can write in Newton, but I wrote like this. Exactly, it's the rate of change in momentum, which is equal to what? Which is equal in Newton in this situation, because I'm dividing by what? Another what? Meter. So it's what? 3 times. So if I put it as this, or I put it as a Newton, it will be the same thing. But I prefer to put it in this way. Okay, no problem. You can do both. Yeah, because the rate of changing momentum is the force. Yes, correct. Excellent. Let's move on. Next. Projecting water from the pipe causing a force to be exerted on the pump. Action reaction. Explain the direction of the force on the pump. Where? In which direction? In the opposite direction of pumping the water. Exactly. In the opposite direction, okay, of pumping water. Why? I'm explaining why. The opposite direction of pumping water. Why? Exactly. Due to Newton's third law of motion. Exactly. Due to Newton's third law of motion, as the water pump pushes, as the pump pushes the water, as the pump pushes the water pushes it back. Pushes as the water, I'm sorry, the water pushes, comma here عشان نميز, pushes it back. Okay, now here I'm explaining. That's why I have to explain Newton's third law. What's happening exactly here? For every action, there is an equal opposite what? Reaction. طيب في اوكي لازم نكتب هون ايش؟ pushing it back by an equal force. ليش مش عم بتغير اللون؟ by an equal force. An equal force. Opposite force. تمام. If you write push is the same as pull as force. Okay. تمام. شكرا يا أمير. Yes, bravo. شكرا يا شهد. Excellent. طيب. What they ask here? Initially, the pump is turned off, and the fireboat moves forward through the water, okay, at a constant speed. The boat engine provided a constant force. When the pump is turned on, the water is projected forwards, and the fireboat slows to a lower constant speed. Explain why boat now has a lower constant speed. Your answer should refer to the horizontal forces to the boat. They give us a hint for what we have to do. طب ها شو اللي بصير هون؟ Yes. Yes. Initially it was at constant speed. Why it was at constant speed? Because the forward force by the engine. خلينا نشوف بالله شو بعثوا لي الشباب أجوبة. هي في أجوبة. Initially resultant force acting towards was 0 because and it was turned off. Okay, and when it turned on, the reaction of the water have in the same direction of the drag force. أحسن من friction, drag force from the water. Okay, so backward force is greater. Okay, causing what to slow it down. طيب شكرا يا حمزة. Another answer. Hamza, you get 2 marks. You lose a mark. Okay, why? I'll tell you why now. Another answer. Yeah, salam. You fix your mistake a little bit, but there's something else. في ناس بعتوا جواب. خلينا أقرأ. Okay. Forward force does not equal the backward force. Drag increases. Okay. which slows down the boat. No, drag does not increase. The backward force on the pump increase, make both drag and the pump force backwards more to slow down. Okay. Then to reach a lower, yes, exactly. شكرا يا نور، شكرا يا حمزة. خلينا نشوف كيف كان توزيع علامات على المارك سكيم. هلا الفكرة إنه زي ما أنتم حكيتوا initially the forward force or the thrust force or the engine force was equal to what the backward drag force. So that's why it was moving forward at constant speed, because the same engine provided this force. Now, as we pump the water forward, that means that there's a force backward on the boat or the on the pump backward with the same direction of the drag, making the resultant force in the opposite direction. That's why it slows down. So as it slows down, what happened to the drag force? Reduces. And again, the drag force plus the pump force backward is equal to what? To the engine force forward, and they are balanced. That's why it returned back to a lower constant speed. Let's move to the answers here. Okay. Look what they said here. Initial speed is constant because the drag was equal to the force. The resultant force is 0. Turning a pump, making a resultant force backward. Okay, so the boat slows down. And as the speed decreases, the drag force becomes less. Okay, until the forces are balance again. So if I want to write this down exactly, shukran, what I would say, initially the engine force was cancelled or equal or was balanced by the drag force. The drag force as it moves at steady speed. And by turning the pump on, the force on the pump backwards, the force on the pump backwards شو بتعمل؟ makes the resultant force backwards. The resultant force backwards to this rate, and as and as the speed decreases, as the speed decreases, the drag decreases until until the resultant force is 0 to move with a lower speed, until the resultant force decreases. So I don't write like this, decreases, and continue at steady lower speed, and continue at lower steady speed. Now let's move on to question 15. It's a static question. What they ask here. يلا جاهزين؟ أرجع باك؟ حاضر هلا برجع باك. أوكي. Okay. Question 15. In a bungee jump, the bungee jumper falls from a height platform while attached to an elastic cord. The cord is also attached to the platform. Okay. The cord slows down the bungee jumper down so that he comes to rest before reaching the ground. Okay. The cord slows down the bungee jumper and so he comes to rest before reaching the ground. The fall can be divided into what? 3 stages. Okay. What are the 3 stages as you can see here? Okay. Stage number one, the jumper is in a free fall until what? The cord starts to stretch. So from here to here, it's fall freely. Okay, the cord start to stretch. Okay, sorry, let me connect it to the electricity. Okay, the cord is stretched until the acceleration of the jumper decreases when it starts to stretch to what? To 0. So the acceleration becomes 0. The cord continues to stretch until the jumper, okay, is momentarily, okay, at what? Momentarily at rest. So that means acceleration, constant speed, deceleration until what? He is at rest. These are the 3 stages. Okay. Now what they will ask here? It's a static question. They give us a whole page empty. Explain in terms of work done. We have to mention work. Work done, okay, where? Work on the cord, because we stretch it, okay? That means I'm talking about elastic potential energy in the cord. Okay, so the work done on the cord, okay, how the kinetic energy, they ask about how the kinetic energy of the bungee jumper changes during the 3 stages. They ask about the kinetic energy, how does it change? Send me your answers. send me key points or answers, whatever you want. هاي في واحد بعت لي جواب كامل. Initially, the bungee jumper has gravitational potential energy, so work equal. Okay, تمام. So work done by gravitational potential energy. Okay, jump the horizontal initial speed, potential energy converted to kinetic energy, and other dissipated due heat and air resistance, so the work increases by. طيب, that's for stage number 1. شكرا يا حمزة. حمزة بعت لنا a whole thing about the first stage. طيب, who can send us keywords? Only keywords. What increases, what decreases, what the work done. And here, don't forget, I'm talking about work done in 2 different situations. Work done on the cord, okay, or work by what? By what? By gravity. So I'm talking about what here? He has what? Initially, gravitational potential energy and falls, okay, to convert to other forms of energy. طيب. Who can send us any other ideas? Okay, elastic cord stretches in stage number 2. So the kinetic energy, so elastic potential energy, what increases? Okay, مش مشكلة يا حمزة. What else? I need from all of you to cooperate. يلا. Okay, let's see the mark scheme. Let's see the mark scheme. What they ask, as usual, they give us the table about how many points, how many marks, what are the linkage. Okay, look what they said. In stage 1, the kinetic energy of the jumper increases because of the work done by gravitational force. Okay. In stage 2, the kinetic energy, okay, of the jumper is increased, but at a decreasing rate. Okay, because start to slow down. Because work done on the cord, because the cord now start to stretch. Okay, as well still the kinetic energy increases, but not as the same rate, with decreasing rate. Okay, stage number 3, the kinetic energy of the jumper now it decreases because the work done by the cord is greater than the work done by the gravitational potential energy. Okay, for the jumper to eventually stop, or he comes to at rest because the total work done by the gravitational potential energy is equal to the work done by stretching the bungee jumper, and the kinetic energy start to decrease. شكرا يا حمزة. برافو حمزة. بعت لنا كثير ideas. مين كمان باعت لنا؟ شكرا يا شباب. يس يسلموا ايديكم. طيب if I want to write the answer I'll write it in these three ways. يعني لازم نكتب ايش 3 stages in each stage what's happening here, right? Let's go back to the picture to see what's happening here. We have 3 stages: acceleration, free fall, kinetic energy increases. The cord start to stretch. That means there is increase of the kinetic energy, but with decreasing rate. Okay. Then what? This question, yeah, exactly. This question same to the question in the year 2018 or 2009. Sorry, 2009. Yes, same idea. Yes, same idea. They keep repeating questions. That's why whenever you answer more past paper, you get more ideas. Okay, to know how to answer the question. Yes, stage what? Stage 1. During falling and work done and work done by the gravitational force as GPE decreases to increase what? The kinetic what? Energy. So that means, okay, that means the kinetic energy increase equal the same what? The same decrease of what? Gravitational potential energy. Let me write it between brackets so you memorize it. The increase in kinetic energy equal the decrease in what? In GPE. That's where in the first stage. Second stage, okay. Do you have worksheets? Okay, from yes, I will send it to you. I will send a lot of it to you, okay, during these days, no problem, inshallah. Stage 2, what's happening here? As the cord is stretching, there's work done on it to have what? Elastic energy. So the decrease of the gravitational potential energy is equal to the increase in elastic energy plus the increase in kinetic energy. That's why kinetic energy increases at decreasing rate. Stage 3, all the decrease of gravitational potential energy is converted into elastic potential energy. I'm sorry, all the gravitational potential energy, and because it decreases now, and the decrease of kinetic energy is converted into elastic energy. Elastic energy, since more work is done to on the cord than in stage 2. I think here until it comes to rest, until it stops at the bottom, or come to rest, stops until he بلاش until he شكرا لكم stops at the rest, until he stops at the bottom. Yes, you can have my brain, inshallah. Okay. Now, actually, it's not only the idea here. It's not being smart. Okay, the idea here is being practiced a lot. Okay, whenever you answer a lot of questions, you will see that the ideas, the question repeat itself more, and that's where you will find it in Unit 2 and Unit 3 more than in Unit 1, because in Unit 1 there's multi ideas, a lot of ideas. Okay. Not necessarily. Not necessarily. Not necessarily. I say it in the other way, Hamza. Okay. No problem. Take a screenshot or write it down, and let's move on. Okay, to the next question. Any question here? Do you want me to repeat it again? How do you predict the questions? Later on, I will give you what are the questions that I think that they will bring ideas about it, inshallah, later on. Inshallah. Okay, 16. A steadily increased tensile force. Tensile, that means stretching, it increased the length, okay? A steadily increased tensile force was applied to a sample of what titanium alloy, okay? The sample has an original length, that means 0.40, okay, that's the original length, and diameter in millimeter, that means the radius will be 5.05 divided by 2 multiplied by 10 to the power of what? -3. I have to convert from millimeter to be in what? In meter. Okay. Yes, your chat is working now. Yes. What do you? What's your question, Abdul Fattah? Yes. تفضل, ask. This is your first question. Okay. Nothing. I have just seen having problem with the Zoom. No problem. Okay. Next. What they ask: state a suitable measurements. Okay. State a suitable measuring instrument to measure the diameter of the sample. You know, it's since the IGCSE, it's the micrometer. The micrometer screw gauge. You can write micrometer or micrometer screw gauge. No problem. Okay. Next, what they ask. Part B. They give us a graph, and as you can see, it's a straight line that starts to curve like this until point B. The graph shows how stress varies with the strain for a sample. Okay, this is a stress in megapascal, and this is the strain. Okay, what do they ask? Determine the Young modulus. Who can tell me what's the Young modulus equal? Yes, Young modulus equal what? Stress over strain. That means I'm talking about what here? Yes, I'm talking about gradient. Exactly, gradient. So what's the gradient here? So let's take a point, and this point, whenever it's far, it will be accurate. And if you can use your ruler and make sure that you can draw a straight line to the end somewhere here, and you to be more accurate, no problem. But I will choose this point. It's a straight line, clear point. I will choose it, and I will draw like this. How much is this distance? It's 0.005. It's exactly in the middle. 1, 2, 3, 4, 5. Yes, it's exactly in the middle between 0 and 0.01. Okay, and this is 600 megapascal. So, okay, which is equal 600 times 10 to the power of 6 megapascal divided by 0.005. Is it 0.5 or 0.005? 0.5. Okay. Yeah, 0.005. Okay, and by using calculator, okay, our answer will be how much? 1.2 times 10 to the power of how much? 11 zeros. Yes, exactly. Pascal. Yes, shukran. That's the Young modulus. If you choose any other points further, if you use your ruler and draw a straight line somewhere here, and you choose a point here, you will get the same answer. Yes, actually, I think that here in this type of question there is range of the accepted answer. Let's check. There is range of the accepted answer. Yes, there is range. Look how much they said. It's 1.2 plus minus 0.05. So our answer from 1.195, okay, to 1.25, okay. Right. Let's continue. The graph, okay, the sample broke at point B. Determine the force required to break the sample. They ask about the force to break the sample here. So that means I'm going to take this point here. I'll change the color. Okay. I need to take this point, how much the coordination of it is. And this point is, yes, who can tell me how much approximately the coordination of it? Yes. Approximately, yeah, it's not in the middle. It's approximately 1280 or above a little bit. Maybe write 3 instead of 0. No problem. Okay, don't forget megapascal. Then what? We will say that this is what? 1280 times 10 to the power of what? 6. What this? Yeah, Shabab. What is this? What this value? We know that stress equal force over what? Over area. So they ask about the force. So force equal what? Stress multiplied by area. And the stress, that's 1280 times 10 to the power of 6 multiplied by the area. And we know that the area equal pi r squared. So multiply by pi, multiply by the radius that they give it to us as diameter in millimeter. Yes, 5.05 times 10 to the power of -3 divided by 2, and all is squared. 5.05 times 10 to the power of -3 all over 2, all what? Squared. And by using calculator, our answer will be approximately 2.6. Yes, thank you. Times 10 to the power of 4 Newton. Our answer, it will be 25600 Newton. You can write it in 2 significant figures or 3 significant figures. You can write it 2.56 or yes. Yes, شكرا يا حمزة. شكرا يا أمير. شكرا يا نور. Yes, bravo. Thank you. Okay. Good. So from the graph we find this point. نكتبها هون عشان اللي يرجع يدرس يتذكر هاي من وين جبناها. Okay, this from the graph. Okay. Let's move on. Okay. Triple I. The graph below shows a linear section of the stress strain graph of a sample. Okay, it's a straight line. Okay, linear section. Okay, what they ask, show that the area under the graph represent the work done per unit volume in what stretching a sample. Now we know that the area under the graph, can you repeat the idea of energy density? Okay, I will tell you that. The area under the graph is the work done by volume, and they called energy density. Yes. So they ask about the area here, and we know that the area, it's equal what? Half multiplied by what? Stress multiplied by what? My strain. And we know that the stress is what? Yes, it's force over area. Yes, exactly. We have to show that. The 3 marks. Yes, Abdul Fattah. Thank you. So multiply by what? Multiply by the strain, which is the extension, divided by what? The original length. Exactly. Now look here, ya shabab. According to what you know from previous. Now half force times extension. What is that? Half force times extension. This is what? The work exactly done to what? To stretch. Okay, to stretch an object or a spring, according to Hawke's law. So, and area multiplied by what? Area multiplied by length or multiplied by height. This is what? This is the volume of a wire. Area multiplied by length, it's the volume of the wire. Because I'm talking about a wire here. Okay, so that means I'm talking about what? Work over what? Volume. Work over what? Volume, which we call it energy density. Good? Clear? Do you want me to repeat it? Okay. So the area under the graph, okay, if the stress is the y on the y-axis, is called what? Energy density, and it changes. Yeah. For example, here, whenever the on the graph, whenever the area is bigger here in this graph, whenever the area is huge like this one, that means it has a huge energy density. That means it's very tough material. It can absorb a huge energy of impact. So that's why we call it what? Tough material, right? Okay. Next. The area under the graph, the area under any stress strain graph represented by the work done, okay, per unit volume. Estimate the amount of work required to break titanium alloy sample. Oh, that's a huge question. Now we need to find the area, and there's several ways to do that. You have to, first of all, you have to look to your watch. Do you have enough time? If you have enough time, let's go and move and do the question. If you don't have enough time, don't do it. خلاص يلا. السريع, try to estimate approximately how much is the whole area, the triangle here, the trapezium here, whatever. But if you have enough time, and they put 4 marks on it, that means approximately 4 minutes. Okay, you have to divide this whole shape, okay, into what? Into small rectangles. Okay, this is the whole shape until B. Each, into small squares. Each square is this. This is my each square that I will find it out, which is 200 multiplied by 0.01, 200 mega Pascal times 2 times 0.01. Okay, how many squares do we have inside this shape? Okay, let's say 1. Okay, let me write them down. Okay, now let me change them. the color. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20 what? 23. Okay? Now, as you can see, this one is not complete. There's a small what? Section here. I'll cancel it with a small section here. So how much is this now? 24. And this one, with this one, I will say what? 20 what? 25. Okay? And this one is approximately half with, let's say, this one. With this one, it's what? 26. Okay? Now, here I have the same thing. I have approximately here and here less than a half, and this one with this one also less than a half. So I have another one, so 27. And here approximately 28 for both of them because it's half approximately. And these two half approximately 29. And these two also half, which is approximately what? 30 squares. So what I can do here, they ask us to estimate, there's range of the accepted answer. So area equal, okay, 30 times what? The area of each what? Square. So 30 times, how much the area of each square? It's 200 megapascal times 10 to the power of 6, multiplied by the width, which is what? 0.01. And by, okay, by using our calculator, okay, how much our answer? It will be approximately 6.0 times 10 to the power of what? Of 2, 600. It will be approximately 600. لا خلينا نشيل هاي مع هاي بيطلع قد ايه الجواب؟ 600 times 10 to the power of 6. Yes, 600 times 10 to the power of what? 600 times 10 to the power of 6. Yes, 7. Yes, okay. 60 times 10 to the power of what? Of 7, or 6 times 10 to the power of what? Of 8. هلا هون 0. Are you sure يا حمزة؟ نور؟ okay. يعني 7. Okay. My mistake. I'm sorry. 6 times 6.0 times 10 to the power of 7 what? Joule. So now it's supposed to get minimum 2 or 3 marks because what I tried to estimate how much is the area. So let's go to the divide by the volume. Okay, yes, exactly. Here, this is the what? Here it's what? The energy. Excellent. Here, how much is the what? Energy. I didn't forget by volume. Yes, thank you. So the volume of the whole sample, how much is the volume for the whole sample? It's pi r square multiplied by what? By L or by H. So how long it is this sample? Did they give us? Yes, this is the sample, has a length of 0.4, and the area, we've just find it before, it's pi multiplied by 5.05 times 10 to the power of -3, okay, divided by 2 all squared, okay, multiplied by the length, which is times 0.4. Then our answer, which is the energy density, so this is the first step, the second step. Third step, we will find our energy density, which is, okay, energy density, which is 6 times 10 to the power of 7 over the volume that we just find it here. And how much is the answer? Is this the volume? Shukran. The volume, it will be 1.04 times 10 to the power of 4. And how much is the whole answer? If you please give me the whole answer. 1.04 times 10 to the power of 4. Yes, how much is the whole answer by using calculator? Yes. يلا يا شباب, tell me. 5,700 watt 70 joule. Okay, per cubic meter. Per cubic watt meter. So 5,800. Are you sure? Is this the correct answer? Because this volume is big. Ah, yes, we have -4. Okay. ماشي. We have -4 here. So here it will be -4. Check if you please your answer. Check if you please your answer. الأرقام. Check if you please. Is this correct? Is this the volume, correct volume? Okay. So I doubt that this is the answer. It's a huge compared to our answer. طيب. How much did you get now? Can you check if you please? This is much bigger. Hold on, this is much bigger. Let's check the mark scheme. Look what this said. Area, it's between 60 to 62 megajoule. We find it 60. طيب. Divide by the what? The volume of the sample, and the volume of the sample, it's 0.4 times what? I don't know why they put. This is the cross-section area, and the answer was 8 times 10 to the power of -6. If you please check, is this the correct volume? Because maybe our volume is not correct, because they say different answer here. And the volume here is how much? Approximately 8 times 10 to the power of -6. Check if you please the volume here. We don't have much time. Yalla. Okay, 8.01 times 10 to the power of -6. Thank you. We put it here. This is meter cube. We put it here. Okay. And the answer 8.01 times. You have to be accurate by using calculator. Don't mess up with the calculator. So how much is the answer now? Yes. Now how much is our answer when we divide these? -6. Okay. 0. Okay. How much is the answer? We still don't get the correct answer. 60 or 6 times 10 to the power of mega. I don't know. The mark scheme give us a different answer. We did correct things here. طيب مش مشكلة بيطلع الجواب approximately, okay, as you told me, a value, and this value we have to what? Look here يا شباب. Each square, they did exactly what we did here. Okay, how many squares did they say? There's 31 squares. I put 30 squares. Okay, the volume, okay, multiplied by the area. This is the volume. We get 8.01. We have to say that. Okay, work. Okay. I'm sorry. My mistake. Okay, this is the energy density that we just find it out. I'm sorry. شباب ليه خربطتوني هيك؟ طيب. So area like this. This is what? This is the energy density. Now they ask about the work. So energy density multiplied by the volume is the work, because we know that we need to find the work, which is the energy density multiplied by the volume. So we will get 6 times 10 to the power of 7 multiplied by 8.01 times 10 to the power of negative 6. And the answer is how much? 480. Okay, 480 joule. I think this is the correct answer. طيب. Yes, it's 500 plus minus 20, so we are in the range of the accepted answer. Thank you, Shabab. So again, they ask about the area, which is energy density, and they ask about the work. So we not divide زي ما حكى لي حمزة اللي بعت لي المسج هلا تذكرت. We multiply because we need to find the work, which is energy density multiplied by volume. Because أصلا energy density, as said before, it's the area is the work done per unit volume. We need to find what the work done, so we multiply it by the volume. شكرا يا شباب, شكرا يا حمزة. Okay. Question 17. Question 17. A mass, okay, M, this one, is held in equilibrium by what? Strings attached to 2 clamps, okay, stands, okay. We're here a force meter, and here we have a tension by P, and this force F, they call it. The force of the meter rule is, okay, of the meter score, force of F of the upper string. The force on the horizontal string is P. Okay, the angle made by the upper string to the horizontal is theta, as you can see here. Tamam, it's not to scale. What they ask. A force meter allows the force to be measured by the means of Hawke's law. Hawke's law, as you know, force equal what? K multiplied by extension. Okay. The extension of the spring inside the force meter allowed to stretch the force to read the scale. So how much is the stretching here? Is the scale, is the force, okay? When the force applied to stretch the spring by how much? 15 Newton, this is the force. The spring is stretched by how much? 8 centimeter. So that means, okay, 8 centimeter, they put it in 8 centimeter, I'll keep it 8 centimeter. Show that the stiffness of the spring is how much? Is 2 Newton per centimeter. Now we know that force equal K multiplied by extension. So K equal the force divided by extension, and the force it's 15 divided by the extension, which is 8. And the answer by using calculator, it will be 1.875 Newton per centimeter. They didn't convert it from centimeter to meter. We keep it in centimeter. Yes, shukran ya Hamza. Now let's return back to the picture. Okay, what they ask in the question, part B. When M is equal, they give us the mass. That means we have to find the weight multiplied by 9.8. Okay, 0.55. The value of P was how much? The value of P was 8.5 Newton. Calculate the value of what? Theta, okay, and the extension on the spring by the force meter. How much is the what? The extension. They ask 2 questions here. They ask about the angle, and they ask about the what? The extension. Now, again, ya shabab, to memorize this, to remember, we have an angle here. We have 3 forces, the weight, okay, mg, the force P horizontally, and the force F with an angle. And this force, as they give, we have to find the what? This value to use it in the next part. They ask about the extension. So I have K. If I know the force F, and use it in K, I will find the extension. But before I find the extension, I have to find what the angle by this force. So what are the forces that I have it here? I have 3 forces. The force F, the force P, which is equal 8.5, okay, and the weight downwards, which is what? 0.55 multiplied by what? 9.81. Now, this one, this force, it has an angle of theta, so I'll make resolve by it. So we have 2 forces, one up and one left. F something f something. Yes, f what here? I'll write sine or cosine theta. Okay, no problem, no problem. خلينا نمشي واحدة واحدة. Okay, so here f what? Sine theta, and here f what? Cosine what? Theta. And these forces are equal and balanced to what? To these forces. The force of P, which is 8.5, and the force of the weight, which is how much? Yes, which is 0. How much is the weight? Yes, 0.55 times 9.81. I want to write as a value. No problem. So we have two equations here. The vertical equations, they are equal. The horizontal equation, they are equal. So we know that resultant force equal how much? Equal what? 0. So horizontally and what? Vertically. Now horizontally, we know that f cosine what? Theta equal 8.5. And horizontally, we know that f sine theta equal what? 0.55 multiplied by 9.81. So yes, exactly. We will divide these two equations. So what we will say, f sine theta over f cosine theta equal what? 0.55 times 9.81 over what? 8.5. F with F cancel out each other, so we have tan theta equal the answer. So theta equal tan inverse, okay, for the answer. By using calculator, how much is our answer? حمزة بعت لنا اياها قبل شوي. قد ايه بيطلع الجواب؟ Yes, شكرا يا حمزة. It's 23.4 what? Degrees. Now we find the angle. I will substitute it to find what now? To find the force. So the angle is 23.4 degrees. Now what I will do, I will find the force. So here the force, I will substitute it in one of the equations. For example, here, F sine 32.4, let's say cosine. It's easier, okay? F cosine 33.4 equal 8.5. So F equal how much? How much F? F equal, yes. How much is F? 10.06. Thank you, Hamza. Now I will use what? I will use, yes, I will use Hawke's law. And Hawke's law states what? That the force that I just find it out, F equal Kx, and we just find Kx in the previous part. So 10.06 equal 1.875x. So x equal how much? X equal 5.37 what? Centimeter. 5.37 centimeter. It's a huge question and ask about two things. Again, ya shabab, خلينا repeat the question. What they ask here. We have the force P, okay, we have the weight, and they ask about the angle and the force to find the extension. So what we have here, they say that the mass is 0.55 times 9.81, okay, and the force P was this value. We draw it, okay, we resolve the force F of, okay, by the string, by the spring, okay. So we divide these to find the angle, okay. F with F cancel out, tan theta equal the answer. So tan inverse will be give this value 32.4 degrees. We will use this angle, substitute it in one of the equations, okay. Let's call this equation number 1, and this equation number what? Number 2, okay. So by doing that, شو بيطلع لنا? Okay, in equation 2 شو صار? F cosine the angle equal 8.5, so that's F equal 10.06, and then we will use Ohm's law here, okay, to find what? How much is the extension? It's not that easy. I know. You can take a screenshot now for the whole answer. Any question? How are we supposed to answer this question? It is easy, but long as Hamza said. Okay, we have to know how to resolve, and you know, all of you know how to resolve. It's 6 marks question. 6 marks. It's a huge. Yes, it's a lot. We have to know how to use this information that you know it. Okay, good. But let's move on to, I think this is the last question. Oh, yes, this is the last question, question 18. They didn't talk about viscosity and upthrust force the whole exam here. Okay, so let's see this question. What they ask. A spherical polystyrene bead is immersed in oil. The bead has a diameter of 4 times 10 to the power of -3. That means I have to find the radius, okay, which is 2 times 10 to the power of what? -3. Okay. The bead is released and move upwards through the oil with a constant velocity. Upwards. That means the drag will be where? Downwards. You have to be careful. Complete the free body diagram below to show that all forces act on it. Now we know that there will be 2 forces that act downwards, and it will be what? Complete the free body diagram to show all forces act on it, which are the drag and what? And the weight. تمام. طبعا you can draw them exactly from the middle, okay, or you can draw them as I did here. Next, B. Show that the upthrust of the oil exerted on the bead is about how much. This value, they give us the density of the oil. Now we know that upthrust is equal to what? Density times gravity times volume. So the density, which is 930, okay, times 9.81 times the volume of the bead. The volume is a sphere, so exactly, shukran, 4/3 pi the radius cube. How much is the radius? 2 times 10 to the power of -3. So 2 times 10 to the power of -3. All of this is what? Cubed. This is the volume of the bead. And by using the calculator, how much is our answer? It's exactly 3.06 times 10 to the power of -4 Newton. I will use this value or this value in the next part. Okay, my answer is better. Okay, so that's the upthrust. 3 marks, 1 mark extra to find what? The volume of the sphere. You have to be careful. Stokes' law shows how the viscous drag on the sphere is related to its velocity through the fluid. Stokes' law, okay, is only valid when the bead is moving what? Sufficient slowly on what? On the oil. State the reason for this conclusion. State the reason of this condition, sorry. What is the reason of this condition? Why I need to make it move slowly? Why do I need to make it move slowly? Yes. Bravo, shukran. Yes. Okay, let me see what they ask here. Exactly. Yes, laminar flow. Bravo, shukran. To make the oil flows laminar. شكرا يا شهد وشكرا يا حمزة. Bravo. Good. Next, double I. What do they ask here? For Stokes' law to be valid in the speed of beads through the oil must be less than how much? Something called VR, where VR is 10 times the viscosity of the oil divided by the density of oil multiplied by the diameter of the bead, not the radius, the diameter. Okay. Deduce whether Stokes' law can be applied on this bead or not. It has to be what? Less. Okay. Exactly. We will substitute the values. So what do we have? First of all, okay, what do we need to do? We need to compare. Exactly. So They give us the viscosity and they give us the what? The weight. So let's say VR equal 10 multiplied by the viscosity of the oil, which is 4.9 times 10 to the power of -2, divided by what? The density of the oil, which is 930, multiplied by what? Multiplied by the diameter, which is 4 times 10 to the power of -3, as I remember. Okay, and how much is that? It's 1.32. Okay, 0. Yes, shukran. 0.3 what? 132 meters per second. Okay, that's what VR. I substitute the values. Now let's continue. We need to find, according to this situation, okay, that the upthrust is equal to the drag plus the weight to compare the velocity. So let's return back here. That's why it has 5 marks. So upthrust equal what? The weight plus the drag. So upthrust, we just find it out how much it is. It's 3.06 times 10 power of -4. 3.06 times 10 to the power of -4. And the weight, how much is the weight? Did they give us the weight? Yes, the weight of it equal the weight, which is 1.05 times 10 to the power of -5, plus the drag, which is 6 pi r eta v. I want to find v. Okay, so move this to the other side to be negative, divided by 6 pi r v. So v equal 3.06 times 10 to the power of -4 minus 1.05 times 10 to the power of -5 divided by 6 pi, and the radius it's 2 times 10 to the power of -3, and eta it's given here, it's 4.9 times 10 to the power of -2. How much is the answer here? How much is the answer? Yes, the answer is 0.16 meters per second. Is this value less than this value? Is this value less than this value, as they said? No, it's not, exactly. So what we are going to say, deduce whether Stokes law can be applied, and since, okay, 0.16 is not less than, okay, 0.132. Okay, so we can't apply what? Stokes law. So what we did here, first step, we find how much is VR. Okay, then by using upthrust equal weight plus drag force, okay, we find how much is the velocity, terminal velocity in this situation, and we find that it's less. So that means there is still acceleration. It didn't reach the terminal velocity, or maybe the flow is not laminar. Okay, maybe it's turbulent. Okay, we don't know. And that, like this, we finish this exam. شكرا يا شاهد, شكرا يا حمزة, شكرا يا نور. خلينا, let's go back to the multiple choice questions. Okay, any questions so far? طيب, yeah, let's go to the multiple choice questions. What do they ask? First question, a car moves towards the top of what? Toward the top of a stop sign with a speed of 25 meters per second. The driver applies the brake 20 meters before the sign and decelerates uniformly to rest. So this is U, this is V, and this is the distance, okay, before what? The sign. Which of the following gives the magnitude of the car deceleration. Now we know that v square equal u square plus 2as. Why I use this formula? Because this formula doesn't have time, they didn't mention time. So 0 square equal what? 25 square, okay, plus 2 times a, the deceleration, times what? Times 20. Move the 20 to the other side, 25 squared negative, of course, okay, equal 40 a. So a equal what? Negative 25 square over what? 40. So the answer is what? Is C. Now I will forget the negative because they ask about deceleration, they didn't ask about the acceleration. So the answer is C. Yes, شكرا لكم. Bravo. شكرا يا نور, شكرا يا حمزة. Now next question, what they ask. An object of mass 8.2 kilogram initially at rest, okay, has fallen a vertical distance of 25 meters through the air and has a final velocity of 20 meters per second. Which of the following gives the energy dissipated by air resistance? Now we know that here it was falling, that means the gravitational potential energy initial, all is converted into what? Kinetic energy final plus work against what? Friction. Okay, they ask about this one. They ask about this one. Okay, so the work against friction equal gravitational potential energy mgh minus what? Half mv square. So the values, it will be mgh, which is 8.2 times 9.81 times the height, which is 25. Okay, so the answer is this one. It's C also. Minus half multiplied by 8.2 multiplied by the speed 20 square. Shukran, shukran. Next question. What they ask? I will give you a minute. Give me the answer. The graph shows how the acceleration A of the object varies with the time. This is the acceleration. Okay. Which of the following give the how the velocity varies with the time here? Yes. So which one is the answer? Acceleration time. Which one is the answer? A, B, C, or D? Yeah, send me the answer quickly. 30 seconds. As you can see, it's acceleration. That means the speed increases. And this acceleration increases with what? Changeable rate. So it cannot be constant and cannot be deceleration. So which one is the answer? There is acceleration. And this acceleration decreasing what? Or increasing acceleration? Is it increasing or decreasing acceleration? It's decreasing acceleration. So the answer is what? Yes, the answer is B. Unfortunately, on the mark scheme, they put the answer is D. That's what I remember. Let me check. Yes. Yes. In question 3, they put that the answer is what? Is D. And they say that C is correct because the acceleration is constant. B, that means the acceleration is decreasing. Okay. Aha, bravo, صح. The answer is D. Why D? There is acceleration, and the acceleration increases at decreasing rate. So the answer is D. Yes, bravo. Shukran. صح. So the answer is what? D. There is acceleration, but the acceleration does not decrease. It increases. There was acceleration, small acceleration, increase, more acceleration, but the increase of the acceleration has decreasing rate. Yes, exactly. And we can see this one here. We can see that there is increase in what? In the acceleration. We can see that it's in decreasing rate, unless we calculate it. Question number 4. Question number 4. Yes, I will give you a minute. Yeah, tell me the answer. Okay. Amir, I want to see your answer here. Which one is the answer? شكرا يا حمزة. A student measure the time for the bear wearing falls from different distances s, from height s, from rest. The student measure and plot a graph to the gradient. Okay, the gradient is equal what the acceleration of gravity. Which row shows what? Yes, how much? How can I? Yes, exactly. ها أمير، شكرا يا أمير، شكرا يا حمزة، شكرا يا شهد. في ناس جاوبوا صح، في ناس جاوبوا غلط. Now we know that S equal UT plus what? Half AT what? Squared. So since it's fall from rest, so S, they ask about it, is equal to A over 2 what? T squared. Now that means we have to make what? Okay, the whole gradient is the what? Is the acceleration. If I want to make the whole gradient is the acceleration, so which one is the answer? Which row on the table shows that the gradient is equal to G? Exactly. So I have to multiply by 2. Multiply by 2, so it will be 2s equal the acceleration t what squared, and that's equal to what? Y equal mx plus what? C. In this situation, exactly, the acceleration is equal to what? To the gradient. So the acceleration of free fall is equal to the gradient. So the answer is what? The answer is B. شكرا شكرا برافو عليكم. شكرا يا أمير. Next, question number 5. يلا عشان الوقت. يلا. Question number 5. A student investigate a material from a wire. Okay. Which of the following properties of the wire will change if a longer wire is used? Okay, if I use a longer wire, what will change? Which one of these change? The breaking stress, the density, the stiffness, or the Young modulus? Now, actually, because I'm talking about the same material, so Young modulus constant, doesn't change. And the same thing as density is constant, doesn't change. Which of these will change? Okay, the stiffness. Yes, the stiffness, it will be change. أستاذ الستفنس هي نفسها Young modulus. شو رايكم؟ طيب لا, so the answer is exactly A, the breaking point. Now لأنه صار longer means it needs a greater force, لأنه هذا برضه constant, هذا هو نفسه Young modulus. So the answer is what? Is A. تمام؟ Exactly. شكرا لكم. Question number 5A. The breaking stress will be higher لأنه صار longer. So it needs more force to reach greater strain or greater extension. Next question. Two objects are traveling directly towards each other and they collide. It's momentum. Object A has a mass. Okay, this is A, this is B. Okay, M, U, and V. Okay, has a mass of 2 kilograms, and initially it was moving to the right with a speed of 3. Okay, and object B has a mass of 5 kilograms. Okay, initially traveling to the left. Okay, with 2, -2. What is the total momentum for both of them? They didn't ask about the final velocity, they ask about the total momentum. So the total momentum initially, okay, after or before collision, it will be the same. The total momentum before or the total momentum after, it will be the same. So the momentum initially, total momentum initially, equal the total momentum what? Finally, it doesn't matter. I don't have how much the momentum finally, but I have the momentum initially. Okay, so it will be mu for A plus what? mu for B, and they have to be equal. So it will be 2 multiplied by 3 plus 5 multiplied by what? -2. And the answer will be how much? Here, 6 minus 10, and the answer, it will be -4. What do I mean by -4? Here I put the -4 what? For the left. So the answer, it will be what? What's the answer for question? Yes, it's A. Question number 6. It's A. 4 kg/meter per second to the left because there is negative here. Good. The total momentum before equal the total momentum after. So not action and reaction, they have to be in opposite direction. No, it's not like this. Okay. Question number 7. What they ask. A student determined the terminal velocity of the ball bearing as it falls through oil. He releases the ball bearing at point V. Okay, it starts to accelerate from here to the air. Then, okay, and measured the time taken to the fall and the distance. Okay, but which 2 points should he use for measure the distance? Which 2 points he should measure the distance? Which 2 points? Exactly. لا في ناس كتبوا غلط الجواب. Be careful. Exactly, between X and what? And Y. So the answer is C. Why? Here it's accelerate, then what? As it enters, it's affected by what? By upthrust. Then what? Slows down, but there's what also? There's a drag, okay? It reach here, okay? And this here, it reached a terminal velocity. Before it reach the ground approximately, because there is a small area here, this is a small region, there will be more turbulent, okay? So it will not reach, it will have lower terminal velocity because what? There's more eddies, but I want to find the viscosity. So, okay, for this material, so I will measure from X and Y, not as it reached the bottom. Okay? شايفين هاي كمان experiment. Okay. It reaches terminal velocity between X and Y, but Y and Z, since it's close to the surface, there's more eddies because the fluid cannot be flowing laminar in this situation. Okay, question number 8, which is easy. Which of the following is a vector quantity? Yes, it's momentum. And the rest are scalars. شكرا. Yes, the momentum. شكرا يا عبد الفتاح. شكرا يا شاهد. شكرا يا كل اللي جاوبتوا. كثار اللي جاوبوا. ما شاء الله عليكم. Number 9. Okay. Which of the following statement is not correct for Newton's third law pair? Okay. The force acts, okay, act in the opposite direction. The force act on the same body. The force act are the same type. They have the same magnitude, and the answer exactly it's B. شكرا يا شباب. برافو يا صبايا. الله يعطيكم العافية. The action and the reaction, they do not act on the same body. Okay, in 2 different bodies. Okay. Last question. وهيك خلص الوقت. Okay. Locomotive pull a train at constant speed against the force of how much? 8,400 kilonewton. Okay. The output power of it is how much? 70 megawatt. Which of the following give the time, okay, in seconds for it to pull the train a distance of how much? 1 kilometer. Yes. Yes. How did you know? Now you send me the answer. How did you know? What do we have to say? Now we know that power equal what? Work over what? Time. So that means time equal what? Work over what? Over power, right? So that means the work, which is the force, multiplied by the distance, which is 1,000 meters, because 1 kilometer it's 1,000 meters, divided by the power, which is supposed to be how much? 70 times 10 to the power of what? 6 megajoule. Here they put it 7 times 10 to the power of 7. It's the same answer. 7 times 10 to the power of 7. It's same as 70 times 10 to the power of 6. So yes, correct. The answer is what? The answer is C. الله يعطيكم العافية يا شباب. That's it for this year.